Now, this is a problem from JEE Advanced 2020. It's on oscillation and electrostatics combined. It's given that one end of a spring of negligible unstretched length, that is the natural length of the spring is 0, and spring constant K is fixed at the origin 0, 0. A point particle of mass m carrying positive charge Q, this is attached at the other end. Entire system is kept on a smooth horizontal surface. When a point dipole P, this one, pointing towards the charge Q, is fixed at the origin, the spring gets stretched to a length L and attains a new equilibrium position. See the figure below. If the point mass is now displaced slightly by delta L from its equilibrium position, release is found to oscillate with a frequency 1 by delta root K by M. The value of delta is. Now we will analyze the present equilibrium condition. So present equilibrium condition, there is the dipole, and at a distance L from the dipole, the field due to the dipole, the electric field due to the dipole is 2kp by L cube. So the charge Q will experience a force here, that is Q multiplied by 2kp by L cube, and the spring force, obviously the natural length of the spring is 0, so the spring force is KL. So now we can equate this. KL is equal to Q 2kp by L cube. So we get somehow this K, I'll do that K, right? So this is K naught actually, because you'll get confused. This K naught is the Coulomb constant, is 1 by 4 pi epsilon naught. Otherwise, you have this K, this small k is the spring constant given here also. So rather the Coulomb constant, I named it as K naught. Okay. Now, so here we get K spring constant L to the power 4 is twice K naught Coulomb constant P into Q. Let's make it equation 1. Now it's given that when the point dipole P spring is stretched to length, that's okay. If this point mass is now displaced by delta L and release found to oscillate, delta L, or rather I take delta L is equal to X. We are more used to that actually. So when delta L, so here is the point charge, the distance is L plus X, so the force is Q 2 K naught P, K naught Coulomb constant, remember it, divided by L plus X cube, and the electrical forces, so that's equal to, we have, so this is the electrical forces due to the dipole, and here we are going to write the spring force. So it is K spring constant into L plus A. So the displacement is here, so the net force to the left is proportional to X. So K L plus X, this is the net force to the left. Okay, net force to the left minus 2 K naught P Q by L plus X to the power, to the power 3, L plus X to the power 3. Now we can write here, now we can substitute, right, from this equation, from the above equation, 2 K naught PQ is equal to KL to the power 4. So in this I will write K L plus X minus, let it be L plus X cube, and here on the numerator you have K L to the power 4. Now K L to the power 4, so again I will write F net force is kl plus x, let it remain, minus kl to the power 4. Now here I write here L cube and 1 plus x by, so I have 1 plus x by L to the power minus 3. So that is kl plus x minus kl into 1 minus 3x by L. So therefore you have kl plus kx minus kl minus plus 3kx, so that is 4kx. That means we have, see this setup, when you move it by x, the force is 4kx. The constant of proportionality is 4k, and as you know that the time period is 2 pi root over of m by the proportionality constant 4k. So here you have to find frequency. So frequency is 1 by 2 pi root over of 4k by m. So this will come out, so 1 by pi root k by m. So here you have to find delta. So delta is equal to pi. If you compare this equation with the equation given, this delta, so delta is equal to pi. Okay, that's it.